In this video, we're going to look at finding the linearization of a function at a particular point. So, in this problem, we're given the function f of xy equals y plus sine of xy. We're being asked to explain why the function is differentiable at the point 0, 3, and then find the linearization at that point. Mentioned in a previous video, a section or two ago, that as long as we have nice functions, the functions will be nice as long as they're defined. So nice may take on different definitions. In this case, nice for us is differentiable. We know that every polynomial, every rational function, every trig function, every inverse trig function, every exponential function, every logarithmic function is differentiable as long as you can plug the number in, minus if there's an endpoint. Like if there's an endpoint for an inverse trig function, you can't differentiate the endpoint, but other than that, you can always differentiate those types of functions. So this is a sum of a polynomial, y, and a composition of a trig function and a rational function. We have absolutely no issues with differentiability unless we try to plug in 0 for y, because every function there is a quote-unquote nice function. Okay? So, in particular, we notice that we can put the point 0, 3 into the function. We have no issues with that. Since that point's in the domain and the function's not a crazy function, it's differentiable at that point. All right, so now we'll take our partials with respect to x and with respect to y. With respect to x, we treat y like it's the constant, so that first y goes away when we differentiate. Derivative of sine is cosine, so that's where the cosine of x over y comes from. Again, we're differentiating now the inside with respect to x, so the 1 over y is a constant. Derivative of x is 1, so that's where that extra 1 over y comes from out in front. So for the partial with respect to x, we get 1 over y cosine of x over y. When we do the partial with respect to y now, we do need to differentiate this y. We get a 1. We also still differentiate this part. Again, outside function will be sine, so derivative of that is cosine of the inside. Now we need to differentiate the 1 over y. Derivative of 1 over y is negative 1 over y squared. The x is a constant, so that's why we get minus x over y cosine of x over y. Now that we've found the partials, we can figure out the numbers that we want to be able to form our linearization. So we're going to put the point 0, 3 into each of those partial derivatives. When you put 0, 3 in for the first one, you get 1/3 cosine of 0 over 3. Cosine of 0 is 1, so you get 1/3. In the second one, we'll have 1 minus 0 over 3 squared times cosine of 0 over 3. Well, 0 over 3 squared is 0, so we just end up with 1 in that case. If we want the linearization at 0, 3, we also need to know what the z-coordinate is. So to find the z-coordinate, we'll plug in the xy coordinates into the function. We get 3 in that case, because you get 3 plus sine of 0 over 3, and sine of 0 is 0. Now we're ready for the linearization. Remember, the linearization formula is to do the function value plus the partial with respect to x times x minus the x coordinate, in this case x minus 0, plus the partial with respect to y times the y minus the y coordinate, which in this case is 3. We rearrange things and we'll get 1/3 x plus y for our linearization. Again, we can also just think of the linearization at the point is the same thing as finding the equation of the tangent line at that